Hello, everybody. My name is Tim B. Green, and this is Crush It Club, episode 6. So this is kind of a book review and a commentary with sort of a book review with an agenda to show science rather than woo. So I read this book specifically for that purpose. I listened to this book for the specific purpose of checking in on my own understanding of quantum mechanics, such as it is. And it turned out it was not bad. I didn't learn a ton more, but I certainly learned it deeper and with more understanding, and reminded myself of stuff, and happily validated that I did actually have a general clue, though I couldn't do the math of it to save my life. I understood it pretty well. At least I know what it really is. So here's the problem, though. In this book, it was wonderful in that it put it in pretty plain language. Most of it, they do discuss some formulas, but they don't go into much depth. It's still probably not going to be a light book for your average listener, including myself. It's not really hard, but not really light. You couldn't listen to it casually and really follow what was going on. But it was interesting, and it talked about the history of it, and it introduced me to a fantastic word, which I now love, and you'll probably hear a lot: fruitloopery. This is a phrase which means to describe things that are unscientific, pseudo-scientific, mystic, metaphysical, just plain nonsense, using scientific phrasing, which is often knowingly or unknowingly completely misunderstood by the person spouting those scientific words. So to be able to say quantum mechanics is not the same as knowing what it means or understanding it, even on the level that I do, which is not that much. Okay, so this is the problem. They say, oh, look at what happens with quantum mechanics. You have a cat, and you have the experiment, and until you look inside there, you don't know if the cat is dead or alive, so therefore it's dead and alive simultaneously. Unless you look in the box, in which case it's definitely dead or definitely alive. This is a famous thought experiment by Schrödinger, who was a contemporary of Einstein's, and they had a lot of debate back and forth, but Einstein throughout his life was uncomfortable, and he called something we're going to talk about in a second, spooky action at a distance, which is known in quantum mechanics as quantum entanglement. And this is the stuff that the woo people say proves things like the law of attraction and quantum manifestation and other fruitloopery that they've really embraced. And I've heard it online recently, which is why I decided to do this episode, to make sure what I understood was not nonsense. I'm always open to re-education and enlightenment of something, but when you go and you find out the evidence you had, the knowledge you had was correct, I can confidently once again dismiss all the metaphysics that people claim having is proven by quantum mechanics is just nonsense. And that was a large portion of this book, talking about exactly that. The actual practitioners, the geniuses who do this kind of work in quantum mechanics, I believe they were the ones who came up with this fruitloopery. It's just, it's just nonsense. It has nothing to do with the scientific reality of the stuff. So anyway, this quantum entanglement thing is that two particles are either touching or interact. Now, these are subatomic particles, so like electrons and stuff. And under the right conditions, they sort of, if they travel apart, they maintain the same properties, right? Okay, I'm just being silly, but that's essentially it, that even at a distance, the information and the behavior, the momentum and the position, relatively speaking, or the spin, which is literally a spinning, I believe, of these quantum particles match each other. It's though they can communicate their state across any amount of distance, apparently, instantaneously. And that's the spooky action at a distance, or quantum entanglement. Here's the problem. For this to happen, they first of all had to share space. They had to be subatomic, or they could be macroscopic, but pretty damn small. Here's where we are on the state of that. Let me first of all make an analogy. Saying that quantum mechanics proves the law of attraction is like saying a donut is a Large Hadron Collider. So the Large Hadron Collider is a donut-shaped tube, magnetic bottle that they use at CERN in whatever, I believe it's CERN, Switzerland, where they have the big particle accelerator. And although it is the shape of a donut, let's think of the donut as the Wu claims, the FRUITLOOPERY about quantum manifestation, and the Large Hadron Collider as the Large Hadron Collider where real science happens. They are not the same thing. They're just the same shape. But the Wu community doesn't even have that much in common. There's not that much shared between their claims of using quantum science, quantum mechanics, and the way they describe quantum entanglement, which I just described. They basically claim that that's what's happening is, oh, well, you think of some happy thought and then it's manifested in the universe and is drawn towards you. That's all nonsense. There's no scientific proof of this whatsoever. So essentially, I like to think of it this way. Since a donut and the Large Hadron Collider, which are both toroids or donut shaped, don't have much in common, and Wu and quantum mechanics even have less in common, I like to think of it this way. Quantum mechanics is a gorilla, and the Wu explanation of quantum entanglement and quantum manifestation and all that kind of nonsense is a cookie. So the lack of similarity between a cookie and a gorilla is probably a good analogy of how similar quantum mechanics, the real stuff, is to the Wu. Okay, so let's talk a little bit more about the quantum entanglement. So the reason it's basically irrelevant to us, and all that is relevant really, is Newtonian physics, or the old physics that you learned in high school or junior high, is that it happens on a small scale and usually at temperatures near absolute zero. So there was an article published online on May 8th of 2021 with the title of "Quantum Entanglement Has Now Been Directly Observed at a Larger Macroscopic Scale." So quick and dirty, macroscopic just means don't need a microscope. So a speck of, a piece of hair, a speck of paper, a speck of dust, you can see with your bare eyes or the assistance of glasses in my case. That is macroscopic because you don't need a microscope to see it. So it can be very small. We are also macroscopic, but we're just a whole lot larger. So the largest quantum entanglement that's been scientifically validated in this article, and it was on the website Science Alert, written by David Neild on May 8th, 2021, give credit where it's due, happened at a scale that was 1/5 the width of a human hair. That's the biggest quantum entanglement we have scientifically validated. Okay, so yeah, you don't need a microscope, but I'm not sure it matters very much because we're a whole lot bigger than that scale. So for us, that is you and I, at this scale, quantum physics, and at this speed, relativity, are completely fucking irrelevant. Newtonian physics is the only thing that really matters in terms of causation, how we approach our everyday lives, how we approach our goals, success, and striving for excellence. Stick with the Newtonian physics. You do work, you get results. All this other quantum stuff is pure fruit-loopery. My name is Tim B. Green, and this is Crush It Club, episode 6. Bye for now.